Hello all. So in the last sessions we were discussing about how do we implement simple linear regression using sample dataset and multiple linear regression using sample dataset. So today in this session we will be covering polynomial regression using sample dataset. So we have seen different types of regression models. So third one is polynomial regression. Let's see how do we implement polynomial regression machine learning model using a sample dataset. So when we talk about polynomial regression, it is an extension of the normal regression, linear regression model. But when we talk about normal linear regression, there we have linear data, that is the output is dependent linearly on the input data. But when you don't have linearity between your independent and dependent variable, that is the input and output, we go for polynomial regression. Okay, so as you can see, polynomial regression is an extension of linear regression where the relationship between the input and output, that is dependent and independent variables, is modeled as an n degree polynomial. Okay, so we use this basically when the data that is available is non-linear or the data have non-linear relationship between input and output variables. Okay, so these are the 7 steps that we use for designing polynomial regression machine learning model. First, like what we have done for simple linear regression and multiple linear regression, it is the same except that we have to transform the features into polynomial features, that is step 3. Okay, so first we import necessary libraries and then we define the data set, we transform the given features into polynomial features and then we'll fit the polynomial regression model, we will predict the new values and then we'll visualize the result by using matplotlib. Okay, so when we talk about importing libraries, similar to that, we import numpy as np for handling array operations, we use matplotlib for plotting the graphs or for visualization, and from sklearn.linear underscore model we use the same function here again. Okay, so as I was discussing in the previous class, though we use simple linear regression, multiple linear regression or polynomial regression, the only function which is used is linear regression. Okay, so for multiple linear regression we take different x values. Okay, so here in this case, apart from using linear regression apart from importing linear regression function, we will also implement polynomial features from sklearn.preprocessing. Okay, so this will be actually used to transform the input features into polynomial features which I was discussing. Okay, so numpy for array operations, matplotlib for plotting the graphs, linear regression model, the function that actually implements the linear regression algorithm, and then we'll implement polynomial features which will actually transform the input features into polynomial features. Okay, now let's define the data set. So I am taking an array with x and y. Okay, as you can observe here, I am you can also take nonlinear data because I am not just giving for how much gap are we generating the output based on input. I am just randomly taking some random data. Basically I have taken quadratic data, that is y is equal to x square. Okay, so I am using this quadratic pattern. You can take any kind of data which is nonlinear and then you can apply polynomial regression onto that as well. Okay, so third step here is we will transform the given features into polynomial features. Okay, so here I have taken degree is equal to 2, which means it will transform the input features into polynomial features of degree 2. For example, if x is equal to x1, it becomes x poly. Okay, I am converting x is equal to x1, I am converting that into 1 comma x1 comma x1 square. Okay, after that we use fit transform function to fit that particular data into the polynomial features, that is your normal input array x will be converted to polynomial features and that would be fitted into your x underscore poly function. Okay, so here I am taking a variable called poly underscore features and I am using the function which I have imported from sklearn.preprocessing. I have implemented that with degree is equal to 2 and this poly features I am applying onto the x input and generating x poly, that is I am converting the basic input x features into polynomial features. Okay, so once we are done with this, it is again the same. Okay, we will fit the linear regression model. So I am declaring a variable called model into which I am loading linear regression function and then I am fitting the model with, initially for simple linear regression and multiple linear regression it was model.fit of x comma y, but here in this case we have converted the normal x features into polynomial features. So we declare model.fit of x poly comma y. Okay, so this is the difference. So here I have fit the polynomial functions into the model, and then I'll start predicting the data. Okay, so this is prediction on available data. Okay, so y prediction is equal to model dot predict using this predict function. Okay, so I am using the trained polynomial regression model which I've already developed. Okay, so here into model I am fitting this polynomial function. I am using this model for predicting the y prediction values based on x poly. Okay, that is x poly is nothing but the original x values which are transformed into polynomial features. Okay, now if you want to work on prediction of new data, I don't want to use the existing data, I want to work on new data. Okay, so I am taking a new data, a variable called new data, np.array 11 12 13. Okay, so here I am using reshaping function because I want to take it as a column. Okay, instead of taking it as a row, I want to take it as a column, hence I am using a reshape function. New data poly is equal to your, see, even if you are taking new data, you are supposed to apply polynomial features onto that. Okay, so x is the original x inputs, x poly is nothing but the x features converted into polynomial features. When you are taking new data also, you have to convert them into polynomial features. So here I take new data 11 12 13 and new data poly, that is converting this new data into polynomial features by applying the same, and then I am trying to do the predictions. Okay, so this is how I do the predictions, and then finally I want to display the predicted prices for new data. Okay, I'll simply take a for loop and pass all the new prediction values and try to print the predicted values. Okay, after that we'll go for visualization. Okay, same thing like how we have done visualization for simple linear regression and multiple linear regression. I will apply the same functions. Okay, dots for the original data, a regression line for the predicted data, and then another dot in different color for representing your new data prediction values. Okay, so as you can see, scatter plot which is predicting x comma y, original x, original y, the data as it is given, and I am using scatter plot, that is blue color. Okay, and then I want to plot x comma y prediction. X is same, but this is original y, this is machine predicted y. Okay, so x comma machine predicted, I want to give it in red color. So as I am giving plot, it gives you a line graph. As I am giving scatter, it gives you dots. So dots are for x comma y, original x input, original y output as per the data set given. Line for original x input for which the machine is making predictions, not the original y that we are taking. Okay, on the new data, again I am going for scatter plot, new data, new predictions. I want to go with green color. Okay, here I am not mentioning any cross symbol or something like that, so only dots by default would be displayed, and then plt dot show for displaying the plot. Okay, so as you can see here, these original dots, blue dots are nothing but, see, as you can see, blue dots are nothing but x comma y, that is original data. This line, as you can see, this line, this is not a straight line, we have a curved line because the relationship between input and output is non-linear. Okay, so we get a curved line here. So here this red line represents your polynomial regression line, that is predicted y prediction for given x. When I talk about these green dots, they are nothing but new x values and new y predictions. Okay, so new data, new predictions in color green. Okay, so for degree 2, this is your x axis, this is your y axis, and this is the polynomial regression when we go for degree 2. Okay, so this is how we implement polynomial regression. Just understand that simple linear regression machine learning model is used when you have only one input variable and one output variable which has continuous values. Multiple linear regression machine learning model is used when you have multiple input features and only one output variable with continuous values. Polynomial regression is nothing but an extension of simple linear regression, but here in this case we observe that x and y are non-linear. Okay, there is no relationship, non-linear relationship between dependent and independent variables or input and output features. This is all about 3 different types of regression models using sample data sets. Thank you.